Okay, hi everyone. As you've already heard, I'm Albin and I'll be talking about our work on HarryMotions, that is how we learn to classify relationships in Harry Potter based on emotion analysis. For my roadmap, first I'll give a quick motivation for the paper, then I'll describe the two tasks that we're dealing with, which are emotion classification and relationship classification. I'll describe the methods we're using, our data sets, of course our results, with the spoiler that we'll find Harry and Ron are actually friends. And then I'll give a conclusion and show that emotions can actually help to classify relationships between fictional characters. My motivation usually comes from the digital humanities, or more specifically the computational literary studies, where the goal is to find a computational understanding of literature. That is, we want to get features that can accurately represent stories, the plot in stories, or in this case, the relations between characters in stories. For this specific paper, the goal is to classify relationships in stories based on emotions. As you can probably guess, we will do this in a two-step process, where first we classify the emotions in the text, and then we aggregate these emotions to perform an overall relationship classification for two characters. Our two tasks, as I already mentioned, are emotion classification and relationship classification. Emotion classification is a rather standard NLP task where we have given as input a piece of text and we want to have a classifier that determines the emotions conveyed in this text. In this paper, we perform different variants of these tasks which define the number of emotions. In the most complex setting, we use the full set of 8 basic emotions defined by Plutchik. In a slightly easier setting, we merge some of these emotions and use only 5 basic emotions. And in the easiest setting, we only perform binary polarity classification, that is, classify texts as positive or negative. The second task, the relationship classification, gets as input a pair of characters, and the supposed output is the relationship between those characters. In this paper, we only focus on a binary output, that is, we classify relationships as either friendly or unfriendly. The methods we're going to be using are GRU and the BERT model for the emotion analysis and a simple aggregation scheme over the result from this first step for the relationship classification. For the emotion analysis, what we do is we use a pre-trained BERT model and fine-tune it to the task of emotion classification. We do this using the FastBERT library, mostly keeping the default parameters that this library provides. As a baseline, we use a GRU model from Evgeny Kim and Roman Klinger from 2019, who perform the same task that we do on the same dataset, who have also introduced this dataset and serve as an inspiration for our paper here. The relationship analysis is a bit more complex because here we have to do some pre-processing to extract all interactions between a character pair and a novel. In order to do this, we use the book NLP library provided by Beman et al. In 2014 for named entity recognition and co-reference resolution. When we've done this, we select all characters appearing at least 20 times in a novel because we want to focus on important characters and mostly include minor side characters, and analyze their relationships. To do this, we need to define what we see as an interaction between two characters, and we simply say an interaction between two characters occurs whenever these two characters are mentioned with at most 10 tokens between them. So we say an interaction is the 10 tokens between the two characters, then of course the two characters plus 10 context tokens on both sides. This gives us a text representation for each interaction between a character pair. When we've defined these interactions, we can then select all character pairs where at least 5 such interactions occur, because again, we want to focus on the most important relations that have the largest influence on the overall novel. When we've made these definitions and extracted all our character pairs and their interactions, we can just apply the BERT model that we've previously trained on all of these interactions and get a label for those. So for each interaction between two characters, we know whether it's a positive or a negative interaction, or we also know which basic emotion is conveyed in this interaction. What we then do is count all positive interactions between two characters and count all interactions between two characters. We define these two counts as pos-AB for positive interactions and all AB for all interactions. We use these counts to define a simple classifier for the relationship between the two characters A and B. In that we say that we classify the relationship as friendly if the ratio between pos-AB and all AB is greater than a threshold parameter alpha and unfriendly otherwise. Alpha is a hyperparameter that we will later tune to the optimal value. Since we're the first ones, as far as we know, to approach relationship analysis in this way, there's no established baseline that we can compare ourselves to. Therefore, we define a simple stratified sampling baseline where we count the true label distribution from our test dataset and just sample from this distribution as a baseline. The first corpus that we use is derived from Fanfictions and contains emotion annotations. This corpus was collected and annotated by Kim and Klinger in the same paper that I've already mentioned for the group, and contains about 1,000 text snippets that mention two characters and an interaction between these two. The annotations in the corpus provide us with directed emotions in these interactions, so we know which basic emotion is involved in this interaction, and we also know which is the causing character and which is the experiencing character for the emotion. This is the directed part. The annotations are for different schemes, so we have annotations for 2, 5, and 8 emotion classes, and we also have some role indicators that are shown in this table. These role indicators mostly have the purpose of showing which character is causing and experiencing, or possibly also masking the character's name, so that the model does not have the possibility to just learn that Harry and Ron always interact positively, and therefore not focus on the actual interaction that is described in this specific sentence. The second corpus is the Harry Potter corpus, which we use for relationship analysis. We've collected this corpus ourselves by just extracting all important character pairs from the Harry Potter novels, as I've already detailed for the relationship classification step. We then gave each of these character pairs to 2 annotators to provide a label for the relationship between these characters. So for example, 2 annotators were asked to label the relationship between Harry and Ron in the first novel. If the 2 annotators agreed, everything is fine. If they disagree, we use a third independent typewriter annotation and ask another annotator to label this relationship again. The third annotator has the possibility to either provide a label or to say that this relationship cannot be labeled, which was, for example, the case with many relations involving Sirius Black in the third novel, because as you may know, if you have read the novel, Sirius is at first painted very grimly and has a very negative image, while towards the end of the novel, it becomes clear that the relationship between Harry and Sirius and Ron and Sirius and so on should actually be very positive. This changes dramatically throughout the novel, so we decided to exclude these relationships that just change too much within the novel from our dataset. Now for our evaluation setting, we have the setup for the emotion analysis task and for the relationship analysis task. The emotion analysis, here we just need to set the number of epochs for the BERT training, which we set to 6 epochs for the 2 and 5 class settings, and to 12 epochs for the more complex 8 class setting. As an evaluation metric, we use the story level F1 score as done by Kim and Klinger, which basically averages first over all annotations in a story, and then again averages over all the stories to perform the final evaluation. This is kind of similar to a macro average F1 score. For the relationship analysis, the first hyperparameter we need to set is the threshold alpha, and we tune this threshold on the first Harry Potter novel, checking which is the best setting that leads to the best classification results on this novel, and then using this setting for all the other novels. We set alpha to 0.4 in most settings, except for the 5-class masked entity setting, where we set it to 0.75. We also need to define which emotions we regard as positive or negative. And in this case, we say that anger, disgust, and sadness are negative emotions, joy is a positive emotion, and anticipation is a neutral emotion. As an evaluation metric for this task, we used a regular macro average F1 score. Good. Now for our results. First task is again the emotion analysis. Here we compare our results from the BERT model to the results from the GRU model that was proposed by Kim and Klinger for this task. We have a directed setting where we use the full information that is available in the fanfiction corpus, that is basic emotion plus causing and experiencing character. And we also use a second undirected setting where we just ignore the direction. So we classify the basic emotion, but not the causing and experiencing character. We find that for almost all undirected settings, our BERT model outperforms the GRU that was proposed by Kim and Klinger, except this one case where they lead to the same performance. For the directed setting, the picture looks a bit different. Here there are actually some settings where the GRU outperforms our BERT model. We assume that this is due to the amount of training data that is available, because in the directed setting, basically we have twice as many classes, and each class only has half as many samples. So we have rather few samples for some of the classes, especially in the 8-class setting. And we assume that due to the lower amount of parameters in the GRU model, this is easier to tune with the smaller data set. For our second task, the relationship analysis, the results are provided here. What we see is the results from aggregating our BERT's predictions versus the results from the baseline. The first thing we see is that we clearly outperform the random sampling baseline by quite a large margin. This is already good. What we can also see is that there is no very clear influence of the role indicator that we select, because for some settings, the entity indicator works better, and for some settings, the masked entity indicator performs better. There is, however, a difference in whether we aggregate classifications for 2 emotions or aggregate classifications for 5 emotions. The 2-class emotion classification setting usually outperforms the 5-class emotion classification. So overall, we reach an F1 score of 59% for the relationship classification when we use the 2-class emotion predictions from our BERT model. These results, I would say, are promising, but there is still room for improvement, which is not too unexpected because we use a rather simple aggregation scheme, which could be improved. As a bonus result, we can also track the relationship over the course of a novel. I've already mentioned that some relationships change drastically, for example, the relationship between Harry and Zehe. This is shown in the green line in this graph here, where we can see that for the most part of the novel, the relationship is neutral or negative. And then at the very end, when it turns out that Sirius is actually a friend of Harry and not an enemy, we can see that the graph clearly goes up, reflecting this change in the actual relationship and showing that they become friends towards the end of the novel. The other 2 graphs in this picture are the relationships between Harry and Ron and Harry and Hermione in the first novel. For Harry and Ron, which is the orange graph, we see that the relationship quickly turns very positive, because in the novel, when they first meet, they immediately become friends, and their relationship stays very positive towards the end of the novel. For Hermione, which is the blue graph in this picture, they have a bit more of a slow start, which is also reflected in the novel because Harry and Hermione do not immediately become friends. They're for a time rather indifferent towards each other, or maybe even a bit negative. But then there's the scene where they fight the troll together. And this scene is actually clearly visible in this graph here, because after that scene, there's the sentence, and from that moment on, Hermione Granger became their friend. And we can actually see that after the part where the sentence and the scene takes place, the relationship in our graph also clearly improves. So we can see that our method is capable of tracking the emotions between character pairs in Harry Potter rather efficiently. To conclude this, in this talk, I've introduced an improved emotion classification method for interactions between fictional characters. I've also introduced a corpus that is annotated with relationships in the Harry Potter novels, which we release for further research. And I've introduced a simple approach to aggregate emotion classifications to an overall relationship classification for fictional characters. As a bonus, we can also use this approach to track the relations between the characters over time and plot relationship trajectories. For future work, as I've already mentioned, we can think about building an improved aggregation function, because currently we're just counting positive and negative emotions and aggregating those. And we may think about using a learned classifier for that. And additionally, it's also interesting to investigate the influence of co-reference errors, because currently we just use automatic co-reference and do not deal with the errors that these co-references introduce to our method. Okay, that's it from me. I'm open for questions, and thanks for your attention.